the learning activities that we like to do as a family, and I especially like to do with my children, is to find your way around the night sky. And that's kind of neat to find certain stars or certain constellations. And it doesn't matter if you're a beginner or an expert, there's always more things to find, and it's a fun activity to do with your family. And the key, one of the keys, or really the key, to finding your way around the sky is to know where the North Star is. And how we do that is, the key to finding it is the Big Dipper. So Tim, can you show us the Big Dipper?
Yeah, I know what that is. It's this, isn't it?
No, not that dipper. The dipper with the stars in it.
Oh, okay, I see what you mean. You mean this one?
Right. Yes, that's the one with the stars in it, and it has 7 very bright stars. And if you notice, it forms a dipper or a ladle. So you start with the handle and work your way around, and then here's the bowl or the dipper. Now, when you go outside, it may not exactly appear here, but let's just, for now, pretend that this is what it would look like, okay? But in 6 hours from now, it would look different. You might see the handle pointing up. And again, if you went out 6 hours later, you would see it's upside down, and hopefully it's still dark out. Otherwise, if it's bright, you can't see it. 6 hours later, the handle's pointing down. And then 24 hours later, to go out the same time the next day, you look, and sure enough, it's in the same position as it was the night before. So let's take our globe out to illustrate what it's like to the rotation of the stars in the sky. So what we have here is the Earth, and we'd be somewhere here on the Earth. And to illustrate this, as the Earth turns, you can pretend my fingers are the stars. And as the Earth turns, it appears to, if you're on the Earth, that yes, indeed, the stars are moving, but it's really not. It's the Earth. There is one exception to that. There's one star that does not move or appear to move. That's the North Star, or Polaris. And the reason we say Polaris is because if you were to draw an imaginary line through the axis of the Earth and followed it straight up, it would point right to that North Star, or Polaris. And as the Earth turns, Polaris stays in the same place. All right, so let's use that Big Dipper to find our North Star. Okay, so Tim's going to point out we're going to have the handle, and you work your way down towards that bowl, and we come to these 2 stars at the end of the bowl, and these are important because they're called the pointer stars. And Tim, what do they point to?
The North Star or Polaris.
Exactly. So if you were to draw an imaginary line up through those stars, it would almost point directly at Polaris. And it's about 5 bowl lengths away from those pointer stars. You know, and it's fun to be able to use the North Star to find things in the night sky, but it's also important to find your way around in direction-wise. So say you got lost in the woods, you would find the North Star, and then you could say, okay, if that's north, here's east. Or if you're driving somewhere and you're lost, you say, I know I have to go to Grandma's house, and that's west. So you find the North Star, and you go your way west. So again, one more time to illustrate how the rotation works and how the stars are turning, Tim's going to turn it and keep your eye fixed on Polaris, and it pretty much stays in the same spot. And all the other stars turn around it. So that's how it works. So what do you say, Tim? Should we go out and try to find the North Star?
Yeah, let's go.
All right.